All right, so in this video, we are now going to take an equation of a line that we have and find an additional line that's parallel or perpendicular to it. Okay, so 2.1. Find the equation of a line passing through the point -4, 5 and parallel to 2x plus 3y equals 6. Now, we've seen this equation before. The reason they had to give us another point is because we could have a lot of lines that are parallel to 2x plus 3y equals 6, right? You could have, I mean, you've seen it on the highway. You've got many, many lanes. So we want one that is specifically through the point -4, 5. All right. Visually, what does that look like? That looks like, so 2x plus 3y equals 6 is right there. And we want one that's through the point -4, 5. Oops. Sorry. There we go. Obviously, we're going to get pretty close to this. So I hope you can kind of see in your mind's eye a line that would be parallel to the red line, but goes through the blue line. That's what we're after right now. Obviously, it's not going to be the same line because the red line did not go through the blue line. And I can further justify that because if I plug in -4 and 5 to the left-hand side, it doesn't equal 6. So -4, 5 is not a solution point to this equation, okay? Alrighty, what do I know about parallel lines? Let's start there. I do know that parallel lines have the same slope. The equation was given to me in standard form, which does not show slope. So if I'm trying to find a line that's parallel to that, I'm going to have the same slope. I'm going to have to know what that slope is. So let's go ahead and rearrange this so that we can see the slope. This is just our original line, our red line, rearranging it to be in maybe slope-intercept form. Might be faster than point-slope form here. So go ahead and move the x over, divide by 3, and we get this. All right, so just back to Desmos for a second. Instead of this one, I can write y equals the -2/3 x plus 3, oops, sorry, minus 3. What did I do wrong? Plus 2? Ah, there we go, plus 2. I remember I have the memory of a goldfish. So when I rearrange the red equation into the green format, notice the same line is there. So I still want this. This is the same line. I haven't created a new equation yet, but I do want the same slope. So the slope I have is -2/3. That's what I want my new slope to be. Y equals -2/3, but this time I want it to go through 4, 5, so I'm going to have to change that y-intercept. Okay, I'm going to have to change that y-intercept. It doesn't actually say I have to keep it in slope-intercept form. So instead of doing that, I think I'm just going to write this in point-slope form because I've just given a point. Y minus 5 equals -2/3 x minus -4 or plus 4. Technically, I'm done. And if they don't specify, or you're doing homework and the computer doesn't specify, then you're actually finished. And this is a beautiful example. Now, let's say you did need it in slope-intercept form, right? You did need it in this format up here. Again, we can always go from slope-intercept form real fast to slope-intercept. I'm sorry, we could go from point-slope form to slope-intercept form really fast by a little distribution. Notice that same slope. 8/3. Remember, when you're multiplying fractions, just multiply numerators and denominators. So 4/1 times 2/3 becomes 8/3. And then add 5 to the other side. Let's see. How many thirds is 5? 15 thirds, 15 7/3. And again, if you need to review your fraction math, please, please, please come see me. But that would be our new equation that runs through this point. Let's go double check that. In fact, let's go see. We plug that in on Desmos. Y equals -2/3. Oops. Thirds. X plus 7/3. Oh, I forgot the x. There we go. Haha, a line that is parallel, the purple line that runs through the point for -4, 5, pardon me. Beautiful. Okay, so it's really not that bad, right? It's not that bad. Let's do it again. Find the equation of a line that passes through point 7, 2 and is parallel to y plus 5 equals 3x minus 1. This one is given in point slope form. So if I were to take this and gouge the information from it, I see the slope is 3. And my point that was given, or at least used, was 1 comma negative 5. Remember, in point slope form, it's always minus. So the fact that it's y is plus 5 means that that was a negative 5 that made it plus, right? Similar to what happened back here with the plus 4. All right, so that was given to me. This is the part that I need, though. This is a slope of 3. And this new one is going to be parallel to it, which again means the same slope. So this is also going to have a slope of 3. But this time, the point would be 2 and 7. And technically, I am finished. Okay, but let's say we did want it in a different format, maybe slope-intercept. You could rearrange this one even easier than the last one. 21 and add 2 to both sides would be 19. Booyah. And that, either one of those, usually what you're given is the format you'll end up in. The exception is standard form. You can make this one standard form pretty easy by just moving the 3x to the other side. All right, same idea, but now perpendicular. Remember, perpendicular slopes are not, perpendicular lines do not have the same slope. They are not the same. They are opposite and reciprocal. Luckily, this is very, very similar to the first one we did today, the equation of a line passing through the point negative 4, 5 and perpendicular to 2x plus 3y equals 6. Almost exactly the same problem. The only different word is perpendicular. That doesn't mean the ideas of slope changed, right? It just means the type of slope changed. So our original line still changes into y equals negative 2/3 x plus 2. That's still the rearrangement of our first line. You don't believe me? Do the math again. But you get this as your slope-intercept form. Now, instead of using negative 2/3, my new slope is not going to be negative 2/3, but actually a positive 3/2. You see how that changed in two aspects. It went from negative to positive, and it also went from 2/3 to 3/2. Okay, so that is the slope that I'm going to be using that will be perpendicular. Now I got the same ideas as last. I can still use point slope form. Okay, that will get me this equation, or I could rearrange, because really this is simplified. Like, this is probably as simplified as it goes. That would be 12/2 is 6, okay? And then I can add the 5, and we get 3/2 x plus 11. So now if we go back to Desmos, we can see y equals 3/2 x plus 11, not subscript 11, plus 11. Compared to the green line, remember the green line is our original line. This is not a parallel line to the green, but a perpendicular line to the green running through that same point 4, 5, okay? And so we get an almost entirely different picture. Cool. Try this last one on your own. You're given a very similar situation. It's even in standard form again, so we'll go through the same routine. I recommend you pause the video and try it. Okay, so 2x minus y equals 7. You can rearrange that. Again, standard form's not bad. It's just not applicable a lot to perpendicular and parallel because we're dealing with slope, right? Standard form is great for x and y intercepts. So we can rearrange that. Move the 2x to the other side by subtracting it, and then remember there's no such thing as a negative y. That's a negative 1y. So we multiply or divide everything by negative 1. We get 2x minus 7. Now we've got a beautiful format for point slope form. And I think I'm either going to leave it there or call it 2x. That would be 16 plus 9. No, it wouldn't. Just kidding, minus 9. That would be y minus 5 equals 2x minus 16. And then add 5, which would go back. Yeah, it'd be 2x minus 9. And notice I did this problem entirely wrong. Not really and not entirely wrong. I think they're beautiful, but how do I know they're wrong? Right? How do I know they're wrong? What did I do incorrectly? Let's go back and let's look at it. Kind of similar along this next one here, so we'll just do it here. All of that seemed really nice and easy. Did I use the wrong format? No, they didn't specify. So think to yourself, what did I do wrong here? There's only one little thing. Let's look at these two lines on Desmos real fast. Y equals 2x minus 7, not plus, and y equals 2x minus 9. If you look at those, are those two perpendicular lines? Miss K, you forgot to switch the slope. Oops, those are supposed to be perpendicular. X, nay. Okay, so I didn't do the one step that you're supposed to do. Okay, so I will change this to the reciprocal slope now. -1/2. Now, when you multiply that in, a lot of this stuff over here changes. So I'm just going to go ahead and erase all that. Sorry if you're working in pen, never do math in pen. -5 is equal to -1/2 x. That would become positive now. 4. Add 5 to the other side, you get -1/2 x plus 9. Now, it's a coincidence that I got -9 and 9. That's just a happy coincidence, probably because it's something to do with 2. It's not going to switch. You're not just going to randomly different y-intercepts. But if I go and I plug that one in, y equals -1/2 x plus 9, we get, oh yeah, that's definitely perpendicular to the other one, huh? Whoopsies. Okay, so watch out for that. Make sure you know what you're solving for. This is basically the same idea as example 2.2, so I'm happy it happened there. Anyways, James is working on his math problem. He wants to find a perpendicular line. He concludes that this equation would be this. What did James do incorrectly? If you look closely, James did something very similar to what I did. He did not choose the correct slope. Now, he actually did change it. But remember, an opposite reciprocal slope was needed here, okay? The point format was beautiful, the point slope format was beautiful, except he used the wrong slope. It should be -1/8, okay? You can always double check by throwing it up on Desmos real fast. All right, that is the end of 3.3. Next up, you'll see 3.4. This last little blurb here is just a reminder of all the formats, and those two special ones, use it as maybe a study aid, and I will see you in the next video.